In this video, I'm going to demonstrate a few basic actions in ArcGIS Pro. Firstly, I'm going to show you how you can create a shapefile from XY coordinate data. Then we're going to look at selecting spatial features based on their attribute values. And then we'll be looking at selecting areas based on their attribute values. And finally, I'm going to show you how you can summarize attribute data numerically. So let's start in Excel. This is a spreadsheet that I made with properties around London. So every row here is a different property, and I've gathered different types of information about each property, starting with latitude and longitude. So this is the geographical reference of every one of these properties. Then also the addresses, so the premise, the street name, the town and postcode of every property. And then some attribute information. So property type, this can be either a warehouse or an office or development land, something like that. And then size and lease value of every property. So if we want to look at this in a geographical display in ArcGIS Pro, what we have to do is save this as a CSV file. And we can do this by clicking File, going to Save As, giving it a name. I've called mine Properties London, and choosing .csv to save it as. So if I click Save here, what I can do is go into ArcGIS Pro. This is the interface of that. I've loaded a base map of the UK, and if I go to Add Data, which is in the Map tab of the top ribbon, I can press XY point data, and that loads this new panel on the right hand side. And for input table, we want to find our CSV file. So here's my CSV file. Make sure not to confuse it with your Excel file. And if I select that, it automatically populates a couple of these rows. First, output feature class is the name that we want to give this new layer that we're creating out of this CSV file. So let's just call them new properties London. And it recognizes that the longitude column in the CSV file should be the X field and the latitude should be the Y field. We don't have a Z field because it's not elevation data, and it also recognizes the correct coordinate system, so we can just go ahead and run that. And if I just right click on the new layer and click to zoom to, we can see that each of the properties have loaded onto the map. So now I'd like to show you how you can select spatial features such as these properties based on their attribute table. So let's right click on our layer and choose attribute table. And this should look familiar to the spreadsheet in Excel that we had before. You can see the latitude, longitude information, the addresses, and then also the property type, size, and lease value. And we'd like to select a couple of these properties based on what kind of property type they are. And you can do that by going again on the map tab of the top ribbon and going to select by attributes. Then for input row, you choose the layer that you want to select features on, and then you can create a new expression. So here we're going to choose property type as the field or like the column title that we want to make a selection on. And we want to say that it's going to be equal to only offices. And if I apply this, what happens is that it highlights both in the attribute table and in the map those properties that are just offices. And I could also set multiple of these clauses just by adding more. So maybe I want to see where the offices are, but it can also be warehouses that we're looking at. So if I apply that, it'll select a few more properties. I can also set an AND statement, which means that it has to be either an office or a warehouse, and it also has to satisfy another condition. And for that other condition, we're going to look at size. So we're going to say that we want only properties where the size is greater than, let's say, 2,000 square meters, and apply that. And what you can also do is look at this in SQL scripting, or even type it in here in SQL scripting if that's preferred. You can apply and press OK. And we now know which properties are either offices or warehouses and have a size of over 2,000 square meters. And if we wanted to create a separate layer of this, what we could do is right click on our layer here and go down to data and then export features. So it selects the layer correctly, and then you have to give it a new name. So let's say properties selection. If I go OK on this, you can see here a layer with only those features that were selected through select by attributes. And what I can also do is now clear my selection in my original layer. So I've now added an additional layer to our project. I've called it economic activity. This data is available in the Living Atlas through the Esri UK content team. I'm just going to turn off our properties layer for a moment so it's a little bit easier to see, and also open up the attribute table so we know what we're looking at. So this layer has information in polygon shape of every local authority in the UK, and it has information on the percentage of part-time workers, full-time workers, self-employed, unemployed, student, and retired people within that local authority. And I've chosen to symbolize this layer on the map based on percentage of unemployed, so that the darker the shade of it, the higher the unemployment there is. And now I'd like to show you how you can select local authorities from this polygon feature by using the select attributes tool again. So for input rows, you pick your economic activity layer, and we're going to create an expression which is based on unemployment. So we want to look at where unemployment is greater than or maybe equal to 8%. That's a pretty high unemployment rate. And again, you can also look at it in SQL format. And then if I click apply here and press OK so that window goes away, you can see that this half of London has a really high unemployment rate, and you can also see it highlighted in the attribute table. Now, if I wanted to extract this data into a separate layer, what I can do is right click the economic activity layer, press data, and export features. And then I'll have to give it a new name. So let's call this selected local authorities, and press OK. And here we have a layer which only consists of those areas with the high unemployment rate. Another thing I wanted to show you is how you can sort of numerically sum up what the attribute data behind your spatial features looks like. So for this, we'll just continue with this polygon layer of economic activity, and we'll open up the attribute table again. And what we can do is choose one of these field headers. So let's just go for unemployment again. And if you right click that and press statistics, it creates a chart here, and that is a chart of the distribution of your local authorities within certain unemployment brackets. So you can see that only a few, maybe one or two of all of your local authorities within this data set have an unemployment rate of between 1.4 and 1.9, whereas most of them fall here between 3.5 and 7.7. And it also gives you that mean of what the overall average unemployment is according to your attribute table. And similarly, you could turn on standard deviation brackets there, or looking at the same data layer, you can select a different attribute field. So for example, full-time student percentages. So you can see that the percentage of full-time student is very low in a lot of your local authorities, which makes sense because students tend to be concentrated in cities. That's your mean percentage of students. And if you wanted to carry out some like parametric tests, you might want to transform this into a logarithmic representation to get it slightly more normally distributed. So you can do something like linear regression. But just in general, this is a useful overview of looking at what attribute information sits behind your spatial features.